Hello students, welcome to her school's channel. Previously, we were dealing with the Kcse 2023 Chemistry Paper 2. We have done question 1. So today, we'll be going through question 2. Part A, we are told complete the following equation. So we're having calcium carbide solid plus water. So these two reagents are used when we are preparing ethylene gas in the lab. So that means we can have calcium carbide solid plus 2 moles of water liquid. We are going to get calcium hydroxide solution, which is aqueous, plus ethylene gas. So to balance this equation, we were supposed to put 2 in the side of water. So we're done with part A. So we go part B. We are told bent 1 Y and E. This is how it's written. It is a structural formula. React with bromine to form compounds B and C as shown in figure 1. So this is figure 1. We're having bent 1 Y and E. That means we're having here a triple bond. So when we add bromine, we are going to break the triple bond and we are going to have a double bond. Then the name of the compound that we are going to get there will be 1,2 dibromo bent 1 in. That means the triple bond is broken down to form a double bond. So when we take this compound B, then we add more bromine. That means the double bond will break up to form single bonds. So that means we are going to get a compound called 1,1, 2,2 tetrabentane, bromobentane. That will be our compound. So we are told draw the structures of compound B and C. So let's check what we have gotten in compound B. We said compound B is 1,2 dibromo bent 1 in. That means we're having a double bond between the first 2 carbon. So we're going to have the first 2 carbon, and in between them we're going to have double bond. Then the other 3 carbon atoms, we are going to have single bonds. So let us fill the other bonds, or the remaining bonds. Remember, each carbon is having a valence of 4. So we put the first one hydrogen, the first carbon again bromine, the second carbon bromine, then the remaining bonds we are going to attach hydrogen atom. So if we confirm this compound 1, 2, 3, 4, 5, it's having bent, then 1, because the double bond is in between the first 2 carbon, that means we pick 1, then we are having 2 attachment of bromo. 1 is in carbon number 1, then the other one is in carbon number 2. So it will be having this name called 1,2 dibromo bent 1 in, like that. Then we go to compound C. We said we are going to have this compound B, then we are going to react with the bromine. That means the double bond breaks up to form single bond. So we are going to have 5 carbon atoms. 1, 2, 3, 4, 5. So let's show all the bonds. So remember, each carbon has a valence of 4, or each carbon has 4 bonds. So we are going to put here hydrogen, this one bromine, here bromine, we put here bromine, here bromine. Then the remaining bonds we are going to attach hydrogen atom. So if we confirm, this one will be, the longest chain is 1, 2, 3, 4, 5. That means we are going to have pentane. We have 4 attachments. That means we are going to say tetrabromo. Then these attachments are placed, the 2 are placed in carbon number 1 and the other 2 are placed in carbon number 2. That's why we are going to have the compound as 1,1. This is 1, 1, then 2, 2, then that's 2, 2 tetrabromo, because we have 4 bromo, 1, 2, 3, 4. Then pentane is the longest chain because this contains 5 carbon atoms. So we go back C. We are told study the flow chart in figure 2 and answer the questions that follow. Then let's first of all summarize or analyze the flow chart. We start with the first step, that's ethene. Ethene is where we are going to start the flow chart. So in step 1, we are having polyethene. So that means what happened to ethene in step 1. So the reagent, if they ask us about reagent in step 1, the reagent will be another ethene. Because when ethene is added to another ethene, the compound will be polyethene. So they can ask us about the process. If they ask us about the process, this is called polymerization process. Polymerization process. Next, they can ask us about the type of reaction or the name of the reaction in step 1. So that's called also polymerization reaction. Polymerization reaction. That's for step 1. So in case they told us to draw or the reaction, we can have ethene reacting with another ethene. So when ethene reacts with another ethene, what is going to happen is that the double bonds in both ethene breaks up. Then we are going to have single bonds. Let's show the bonds. Then remember, the first ethene was having 4 hydrogen. We are going to put it up. Then the second ethene is having 4 hydrogen atoms. So we are going to put it down. Then we are going to close it with it like this. So that's in case they ask us to write the reaction. Then we come to step 2. Step 2 is here. We are having ethene. Then it has been converted to ethane. So they can ask us about reagent again. So the reagent that we need there is hydrogen. So in case they ask us about process, this is called hydrogenation process. It's called hydrogenation. What is hydrogenation? Hydrogenation is the addition of hydrogen to a substance. So next, they can ask us about reaction. The reaction here is called addition reaction. So what is addition reaction? Is a reaction in which one molecule adds to another to form a single product. In this step, we're having ethene molecule being added to hydrogen molecule to give us ethane molecule, which is one molecule or one compound, one product. That's what I mean. So next, they can ask us about condition for this step 2, and the condition, we can talk about one catalyst. The catalyst that we can use there is nickel catalyst. If you don't want to use nickel catalyst, we can still use palladium catalyst. Then next, we are supposed to look for temperature, which is another condition. So this temperature is in between temperature of 150 degrees Celsius to 250 degrees Celsius. But remember, learners, in case we are told the condition for this step 2, you are not supposed to give a range. You are supposed to pick only a number from the range. So that means we can pick 160 or 170 or 180 or 190, even 200. So we're done with step 2. We go to step 3. In step 3, we're having ethene being converted to ethanol. So this can occur in 2 ways. The first way, we can talk about reagent. And that reagent we can take is steam. So when ethene reacts with steam, we require a catalyst there. So a catalyst of phosphoric 5 acid can be used, H3BO4, that is it. Then here, we also need condition. The condition is temperature. So temperature of 300 degrees Celsius is used. So in the other way, the other thing that we can do is that for us to convert ethene to ethanol, we can first of all react this ethene with the concentrated sulfuric 6 acid. Then we are going to get a compound called ethyl hydrogen sulfate. Then that ethyl hydrogen sulfate that we got, we are going to add water. Then the product that we are going to get is called ethanol. We are going to get ethanol plus sulfuric acid. So we proceed to step 4. Step 4, we are having ethanol being converted to ethanoic acid. First of all, we can talk about process there. This process is called oxidation. Yeah, because here, alkanol is being converted to alkanoic acid. Next, we can talk about reagents. So the reagent that we are going to use here is an oxidizing agent. That means we can use potassium manganese 7 or acidified potassium dichromate 6. That means we can use acidified potassium dichromate 6. So we move to step 5. Step 5 here, we have ethanol being added to ethanoic acid and giving us compound D. Let's start first of all by knowing the name of this compound. When ethanol is added to ethanoic acid, we are going to get an ester called ethyl ethanoate. Ethyl ethanoate. Then let's talk about the process here. This process here is called esterification process. Esterification process. Esterification process. Then let's talk about the type of reaction that you can have there. It is still called esterification reaction. Esterification reaction. Here we can have condition in esterification process. The condition one, we are supposed to add few drops of concentrated sulfuric 6 acid. Then we are going to warm the mixture. Warming. That's the next thing. So what are we warming? We are going to warm the mixture of ethanol, ethanoic acid, and the few drops of concentrated sulfuric 6 acid. That's what we are supposed to warm. The next, we are going to go to step 6. Step 6, we are having ethanoic acid being converted to sodium ethanoate. So here we can talk about a reagent. We can talk about a base like sodium hydroxide, because when ethanoic acid is added to sodium hydroxide, we get sodium ethanoate plus water. Or we can take alternatively sodium metal, because when sodium is added or reacted with ethanoic acid, we are going to get sodium ethanoate plus hydrogen gas. Then we conclude with step 7. We start with first of all reagent here. So here we are having sodium ethanoate. Then we have added something in step 7. It is giving us methane. So that means the reagent there that we are going to use is soda lime. Remember, we said for us to prepare alkanes, first of all, we are supposed to have appropriate alkanoate. That's here we are having sodium ethanoate, and we are supposed to add the soda lime, and we are supposed to heat the mixture. So that means the condition in step 7 is heat, or you can say heating. That's the condition. So we have analyzed and summarized the flow chart. What is remaining is for us to go through the questions and pick the answers from the summary that we have done. So we go to question Roman 1. We are told give the reagents and the conditions used in Roman 1, step 2. So step 2 is here. It is ethene being converted to ethane. That's step 2. So that means they're asking us about the reagents. So the reagent used there is hydrogen. So we have that. So we are going to say reagent. The name of the reagent there is hydrogen. Hydrogen. Then as well as conditions. So the conditions are 2. 1, we can talk about the catalyst. We can talk about nickel catalyst. Nickel catalyst. We have written it here. The condition is nickel catalyst. These are the conditions. Or we can use palladium catalyst. Palladium catalyst. Then we can talk about temperature. That's the other condition. Temperature of between 150 to 250 degrees Celsius, but we can pick 180 degrees Celsius. So students, you can pick any number from that temperature range. So that's part Roman A, step 2. So we proceed next to step 7. So step 7 is here, where we are having sodium ethanoate being converted to methane. So that means we are supposed to look the reagent. So the reagent there is soda lime. So we are supposed to write soda lime. That's our reagent. Soda lime. That's our reagent. Then we are supposed to write the condition. We said the condition there is heat or heating. As we can see here, the condition is heating. So we are going to say heating. So next we are going to proceed to Roman 2. In Roman 2, we are having write an equation for the reaction that takes place in step 1. So let's check step 1. Step 1 here is ethene being converted to polyethylene. So that means the reaction we have even written here, ethene plus ethene giving us polyethylene. So we just take that and we put it here. So we are going to have ethene plus ethene. Through polymerization, we are going to get something called polyethene. So we are going to have 4 carbon, then we are going to show all the bonds in each carbon. Then we are having 4 hydrogen in the first ethene, then another 4 in the second ethene. Then we are going to close it like that, and this is polyethene. So we proceed to step 3. What is step 3? Step 3 is ethene being converted to ethanol. We said we can do this in 2 ways. One way, we can add ethene with steam so that we get ethanol. The other way, we said we take ethene, we react with concentrated sulfuric acid. There we are going to get ethyl hydrogen sulfate. We are going to add that product to water so that we get ethanol and also concentrate ethanol and sulfuric acid. So we can pick any. So we can say we can have ethene. Ethene is written like that, ethene, which is a gas. Then we can add water, I mean steam, which is in a gaseous phase. We are going to get ethanol, C2H5OH, which is liquid. That's the first way. Or what else we can do is that we can pick alternatively. We can pick ethene, then we react with concentrated sulfuric acid. Then what we are going to get here is called ethyl hydrogen sulfate. It looks like this. It looks like this. Then we take this ethyl hydrogen sulfate. We take this ethyl hydrogen sulfate. We add water. What we are going to get is ethanol. We are going to get ethanol plus sulfuric acid. So that's again the other way that we can write that equation. This is the simplest equation. So we proceed to but Roman 3. We are told name the type of reaction that takes place in step 4. We go step 4. So we are told name the type of reaction. So let's check the type of reaction. Here we are having oxidation reaction. So here the type of reaction is oxidation reaction. Remember, here we are having the process being oxidation. That means the reaction is also oxidation reaction. So step 2, let's check step 2 from the flow chart. Step 2 was here. We said the reaction or the type of reaction is addition reaction. So we can write here addition reaction. You can as well say hydrogenation reaction, but the best answer is addition reaction. So Roman 4, part 1, we are told draw the structure of the organic compound D. So organic compound D, the way we have said, is called ethyl ethano. That's the name of the compound. But we are supposed to draw. So that means, first of all, this is an ester. It's made up of 2 parts. That's one part from the side of ethanoic acid. So the way we write ethanoic acid is like this. This is how we write ethanoic acid. Then we are supposed to add ethanol. So that means we are going to say plus ethanol. Ethanol is written like this. So when writing an ester, what we are supposed to do, first of all, we are going to remove this whole OH or hydroxyl ion with this hydrogen. When they combine, they are going to form water, because we are told during esterification process, water is also produced as a byproduct. So that we are going to draw now compound D from what has remained. We start with the side of ethanoic acid or the alkanoic side. So we are going to have 2 carbon, then we are going to have its bond being attached to 3 hydrogen in the first carbon. Then we are having double bond with the oxygen. Here we have nothing, so we're going to say dash like that. Then this other side of alkanol side, we are having oxygen here remaining. That's the oxygen, then dash. Then we are going to have carbon being attached to 2 hydrogen, 1 hydrogen there, the other hydrogen here. Then this is a single bond. Then we're having another carbon, then which is attached to 3 hydrogen, 1, 2, 3 hydrogen. So this is the structure of the organic compound D. Then Roman 2, we are told, give the name of the compound D. If we go back to our paper, we are having the name as ethyl ethanoate. So we are going to write ethyl ethanoate. So learners, that's the end of question number 2. Thank you.
On the way.